Alright, so we're going to spend a little more time practicing molarity here. These problems could be a little bit tricky, and they are the unit that chemists use most to violate the Geneva Convention, so therefore I must inflict them all upon you to the maximum degree possible. And this video will give me every excuse to do that, so here we go. So I introduced molarity in the last video, so molarity is moles per liter. I want that solidly in your mind. And in the last video I gave you moles. I gave you a volume in milliliters. I got tricky and you had to convert it to liters. But you always want to take moles of solute divided by liters of solution to calculate a molarity when you're doing this numerically. So, where does it get tricky? Well, we don't always give you moles. Oh, so we can go backwards. We'll talk about that in a little bit. But we don't have a molometer. I don't just set a bunch of grains of sugar on a molometer. It goes like boop, boop, boop. You have 0.01375 moles. It doesn't do that. What I can do is I can put some sugar on a balance. You can tell me how many grams it is, and then I can use the here's a blast from the past, molar mass, to convert those grams into moles and then plug that into molarity. So we're gonna build here. We're gonna build on the idea of molar mass, all the math stuff. And I think there's one more section when we talk about pH that has math, but this is kind of the end of the math for the most part. pH, just know how to use a calculator. That's my advice. Find your log button and all that, but we'll deal with it when we get there. That's not till after this exam, so it's not your problem right now. Whereas all this is fair game for exam 2. Just a reminder, in case you weren't aware, and I'll try to remind you approximately every 43 seconds of that fact. Okay. So, let's put this into practice. We'll do a couple different types of problems, and so you'll have examples of this getting worked forwards, backwards, so on and so forth. So I'll write out a problem, and I suggest, once I have the problem written out, pause the video, take a crack at it, and then see me work it up if you're stuck. And then just watch to a part and go, oh, that's how you start it, and try to take it from there if you're stuck. Or wherever you're stuck, watch what I do, and then finish it on your own and compare to what I got. And I'm not just saying that so that I can get all of you to check my numbers for free. No, it's because I value learning. That's why I want that to happen. So, let's say we've got a solution, right? Can't have a problem without a solution. Alright, so that's as much as I'll border on stupid chemistry jokes, by the way. The molarity of a 200.0 milliliter solution. Oh, look at that, I'm already getting tricky. Watch out. That contains 2.135 grams. This is how you know I've got it pre-cooked. Alright, if you start seeing numbers like this get thrown out by me, I'm working off some notes over here and you don't get to see them. But I do, so you can think I'm really smart at math. Alright, so it contains this many grams of aspirin. Alright, try to make this as painless for you as possible. Alright. Okay, what can I say? So, I'll tell you the molar mass of aspirin in a second. You might have noticed I was very straight-laced through the biomolecules. I had to really focus and draw stuff. I can teach this in my sleep. That's when it gets dangerous. That's when you get all the weird stories and stuff. So, the molar mass, or molecular weight, for aspirin is 180.157 grams per mole. Okay? So we need a molar mass here. If it's a big compound like that, I'll give it to you. If it's a small compound, you know how to add the pieces up. Now, just for fun, this isn't actually needed for the problem, but here is the line drawing of aspirin. Carboxyl group there. And there. There's your aspirin. In case you ever want to know. Think about how far you've come in this class, by the way. I just drew a line drawing like it was nothing, and you probably looked at it and went like, oh, that's interesting. Like, I can interpret that. Like, there's a ring and a carboxyl group and whatever the heck's going on down there. It's a person pushing a wheelbarrow. That's what you're looking at. Can't help but interpret. Alright, so let's solve the problem at hand. I'll give you enough background. So at this point, feel free to pause, take a crack at it, and I'm going to get into it. So we need moles over liters. I have neither here. What do I do? Well, let's calculate the liters first. I showed that before. So I've got 200.0 milliliters. There's 1 liter for every 1,000 milliliters. This isn't going to limit my sig figs, by the way, because it's an exact value, because it is by definition. There are exactly 1,000 milliliters in a liter. The metric system didn't make it 1,001 for a reason. It's 1,000, so I don't have to worry. So I just keep the same number of zeros after the 2. And so I do the math, and it comes out to be 0.2000 liters. So 2 with 3 zeros after it, 2 with 3. Okay. So these are all significant after decimal point. Noted. Okay, so I have liters now, but what about moles? What do I do? Well, pay attention to your units. So I've got to go from grams to moles. So I know I have 2.135 grams. This is known to me. I've got to flip that into moles. How many moles of aspirin is that? Well, if I go over here, there's 180 and some change grams per mole. If I write it like that, grams aren't going to cancel, so I have to flip it. So for every mole of aspirin, there's 180.157 grams. And if that is total Harry Potter wizardry right there, you know, if I just went full Gryffindor on you or whatever, or maybe it feels like I went full Slytherin, I don't know. Hopefully Ravenclaw, because they're smart and not at all pretentious. Then go back to the moles section and review it. That's my advice. By the way, I would be the coolest Hufflepuff ever. Just saying. You know, be like, I'm a Hufflepuff. I breathe oxygen. I could live up to that standard. I don't want to be in any of their houses. For one, I'm not a racist wizard, so I'm out of Slytherin. I was also poor, so I'm out of Slytherin. That's 2 strikes. Like, they would kill me. I would go down in their little dungeon and never come out. I'm a total coward, so Gryffindor is not for me. You know, I would be, yeah, I would just, they'd always be getting into problems, and I would never back them up, so they wouldn't like me. And yeah, maybe I'm smart, maybe I'm not, but I definitely wouldn't want to hang around with Ravenclaws all day. That would just be depressing. They'd be like, oh, did you, they'd be those people like in coffee shops, oh, did you know that blah, 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 blah. And I'd be like, who cares how many toes that, you know, Marilyn Monroe had? I'm sure it was probably actually 10, despite what you read. It's not a big deal. And, yeah, so, Hufflepuff, you know, you just kind of like hang out all day. I don't know, I mean, I'm sure not all of them sniffed glue, so I'm sure there were some I could still hang out with. Anyway, we punched this up in our calculator. Like I said, I can do this stuff in my sleep, so I get a little bored. I apologize. Hopefully people still know what Harry Potter is, especially for like the 10 years I use these videos. They'll be like, oh, I thought you were much younger when they meet me in the year like 2040, and I'm still using these. Alright. Hopefully just because, you know, I just put them online and not because I'm still teaching online only classes because you can't leave your house without catching a horrible infectious disease. Alright, so I've got moles, I've got liters. This is where students sometimes get stuck. You're basically, you feel like you're done, you just did a lot of work, but you've got to use the cunning art of division. You've got to put one over the other and calculate. So, my molarity, I want moles over liters. So my final answer is going to involve dividing 0.01185 moles by 0.200 liters. I've got 1, 2, 3, 4. Never trust those leading zeros. 4 significant figures on top. Another leading zero. Don't trust it. Definitely don't give it your social security number. I got 1, 2, 3, 4 on the bottom, so I get 4 at the end. Pretty straightforward. And it comes out to be 0.05 0.925 molar, and I definitely totally did that in my head and didn't look to the right at a piece of paper with my notes on it. I am a genius. I'm a Ravenclaw with a Hufflepuff personality. Alright, so that is the answer. Hopefully you got there. So when you see a problem like this, why would we talk about grams? Because that's what we actually measure in the real world. I use a balance, I see how much stuff there is. And then when I know what that stuff is, so I know the molar mass, and you'll know the molar mass too, one way or another. Either because I give it to you, or it's a simple compound that you can calculate the molar mass of. And so we can convert that into moles. If our volume isn't liters, make sure it is. Cunning art of division, bam. Final answer. Okay? You don't have to memorize the structure of aspirin, by the way. Alright, so let's look at another problem here. Let's say we're going to make a 2.0 liter solution of ibuprofen, and we want to make a certain molarity. So I'm going to get tricky here. I want to specify how many grams of ibuprofen, even though everybody says ibuprofen, that I know of. Used to take a lot of that when I was still playing basketball. Kept my arms from feeling like they were going to fall off, even though they pretty much were. Shoulder problems don't mix well with that sport. So how many grams of ibuprofen are needed? We're going to get tricky here. This is not going to be like what you saw before. It'll be similar, but see if you can figure out the trick on how to do this. To make 2.0 liters of a 0.0029 molar solution. Okay. So, ibuprofen. Yeah, we were having fun before. What does ibuprofen look like? So we got a ring, we got a carboxyl group out here, got a side chain there. This is ibuprofen. Do you need that information to do this problem? No, not at all, because I'm just going to give you the molecular weight of ibuprofen, and it is 206.29 grams per mole. Okay? Feel free to count up all the carbons, hydrogens, oxygens, add them up, and confirm that number if you like. Or you can Google what is the molar mass of ibuprofen, and it'll probably be right. If you use Bing, it'll probably be wrong. Boom, take that, Microsoft. Think you can search the internet? Who do you think you are, Google? Alright, so we've got a different type of problem here, and I'm going to show a diagram that I saw a student of mine once in the Science Resource Center watching a video on this topic, and the person in that video used this diagram, and I was like, oh, that's a really good idea. I'm going to steal it. So, like all ideas that aren't mine, it's pretty good, and also I have a hard time talking about it because I didn't come up with it. Alright, so this is molarity, this is moles, this is liters. If I take moles and divide by liters, I get molarity. If I take moles and divide by molarity, I get liters. If I take liters and multiply by moles, I get molarity. So I can go this way, boom, and I get molarity. I can go this way, I can go this way and get moles. I can go this way and get molarity. Or I can go this way and get moles. I don't know if that helps. I'm sure there's a lady on YouTube that can do a much better job. But just put your finger over what you want to know, and I'll show you how to put the other two pieces together to get it. If they're next to each other, you multiply. If one's above the other, you divide. Pretty straightforward. And it's like, well, what if I want to know two things? Well, you don't get to. You got to know 2 out of 3 to solve these problems. Did I tell you 2 out of 3 here? I gave you molarity, I gave you volume. Okay. That means we're going to multiply them to get moles. We don't know moles, multiply, we get moles. So that's what we're going to do. So I know I have 2.0 liters, and I have 0.0029 moles per liter. I'm going to break this out a little bit so we can see the units cancel. And this comes out to be 0.00, what is that? That is 58 moles. Okay. Am I done? Have I answered the question? Have I answered the question of how many grams of ibuprofen are needed to make this solution? Or have I answered how many moles are needed? Okay, so I've got moles. That's not grams. I'm not done. So I know I have 0.0058 moles of ibuprofen. I just took my number, brought it down here. And I know that there's 206.29 grams per mole. I want moles to cancel. So that means it's going to go on the bottom to make that happen, which means 206.29 grams goes on top. I'm only going to get 2 sig figs out of this. And so it comes out to be 1.2 grams. And again, I totally did this in my head. I didn't look at notes or anything. Didn't ever use a calculator on this problem. But, you know, if you're a mere mortal, unlike me, feel free to Hufflepuff it up. Use that calculator. Alright, so I think that's kind of it for applied practice. So, you know, keep this figure in mind. But, you know, you can go forwards or backwards with these problems. Molar masses come into play. So if you see grams, you have to have the molar mass to do it. If it's a simpler compound, like something like, I don't know, this guy right here, remember you can use the periodic table. You have the molar mass of sodium, or the atomic mass of sodium, the atomic mass of chlorine, and you'd get the molar mass of this compound. It comes out to be 50 something. You know, I use this example so much you think I'd have that number memorized, but that's just how bad at memorization I am. I don't remember. I want to say 58, maybe it's 54. I don't know. I don't have my periodic table in front of me, so I can't cheat and look at it. But that's what you would do. You use your periodic table, you add it up, figure out what that is. So, we'll call it here. I normally try to make each section about an hour. I am getting close to an hour into this section, and I have 2 out of 4 videos done. So, you guys are having a good time, I'm sure. Alright, so understand how to work molarity forwards, backwards. Don't forget, big capital M means moles over liters. That's the first step. Get comfortable with that idea, and then it's all unit conversions from there. Everything I'm showing you are just applied unit conversions. I just did a unit conversion and a unit conversion. So if you are feeling strong with that topic, you're going to look real good here. It's just a little, not even a change, but just a little bit of an application of that idea. It's the same units over and over again. So it's not miles per hour, now it's moles per liter, or grams per mole, which we've worked with before. So, you know, if it's not clicking for you, just do the best you can. It's not the end of the world. You know, this is not a super math intensive class. This is just a super math intensive section, and it's the last real intensive section. So, oftentimes students struggle with this area. That's fine. Just do the best you can. If you figure it out, that's great. And if you only get it halfway, that's fine. Just, you know, give it your best shot. That's my advice. And hopefully I've shown you enough to get you through it. But if you do have questions, let me know. I suspect this will be an area where I have a lot of questions, because I normally do. Students tend to get a little bit nervous about math topics. But it's not the end of the world. It really is stuff I've shown a couple times. So once you get that idea in your head, it really clicks, you're home free. So just try to get there. Alright, so next we are going to talk about dilutions, which will introduce an equation which is like your best friend in the world. Yeah, that's what we'll talk about next.